Resistance, we get it from Ohm's law. Change in voltage, or the voltage difference across a conductor, is equal to the resistance of that conductor times the current that can flow through that conductor. Resistance is actually the equivalent to friction and air resistance for electrical currents. Now, physically, we found it to be equal. So if this is my piece of conductor with length L and cross-sectional area A, the resistance is given by L over sigma, the conductivity A. 1 over sigma, we also refer to it as resistivity of the material, rho. Rho, the resistivity, it depends on the material, and its units are ohms meters. Resistance depends on the temperature. The dependence is given by this expression through the dependence of rho. So rho would be equal to rho 0, which would be the resistivity at temperature T0, times 1 plus alpha, which is a temperature coefficient for the particular conductor. So it depends on the material. So 1 plus alpha times the change in temperature relative to T sub 0. That would be the dependence of resistance on temperature. Now, resistances that we use in circuits, for the most part, might look like this, in addition to the resistor in a wire. These are what we call carbon resistors, and then we have, like these, higher power resistors that are ceramic resistors. For carbon resistors, we use color codes to figure out their size, their value. So in this particular case, we have the first band tells us the first digit, the second band, the second digit, the third, the number of zeros, and here it tells us the uncertainty in that value, the tolerance. For example, here, blue corresponds to 6, gray corresponds to 8, and red corresponds to 2. So it's 682, that's the numbers we got. So it's 68 plus 2 zeros. 6,800 ohms, which is 6.8 kilo ohms. And since we have gold here, it tells us that's within a 5% accuracy. The symbols we use in circuits for resistors are like these jagged lines. This is the common resistor symbol. This is a symbol for resistor whose value changes, what we call a potentiometer or variable resistor. And this is another potentiometer, but with a tap in the middle. So for example, we can connect a circuit through these 2 points and another circuit through these 2 points, depending on how much how much of that resistance we want in this part of the circuit and the other part of the circuit. And the advantage of this is you can move this to adjust both resistances at the same time to the values you want.